Hi guys, this will be video 1 for the 2012 AP exam, and this will cover question number 1. So this question deals with some water in a tub that is changing temperature. It says it's an increasing function, so the temperature is getting warmer. It's twice differentiable, which means I can take a derivative all the way up to the second derivative at least. And W is measured in degrees Fahrenheit. So the key thing to note here is that the units are degrees Fahrenheit. This is not a rate of change. So I would consider this, as far as your 3 levels, this is the top level. At time 0, the temperature is 55 degrees, so we got to take note of that and not forget it. The water is heated for 30 minutes, beginning at time 0, and 5 of the values in 20 minutes are given in the table. Alright, so let's take a look at A. Use the data in the table to estimate W prime of 12. So as soon as you see W prime of 12, we know we're taking the derivative of W at 12. So we come look at the table and we see 12 is immediately between 9 and 15, so it's the midway point. Normally, if we had an equation for W, we would just take the derivative and plug in 12, but we're going to have to do some sort of approximation. So the approximation that we're going to do is we're going to find the slope at 12, so W prime of 12, and we're going to find it by estimating the slope of the points around it. So that would be W of 15 minus W of 9 over 15 minus 9, which is going to equal, let's see, 67.9 minus 61.8 over 15 minus 9 is 6. This is a calculator section, so if you don't trust your basic skills, and sometimes I don't, so I'll just do it real quick. 67.9 minus 61.8. And I get 6.1 divided by 6. And I get approximately 1.01666 repeated. And show the computations that lead to your answer. Done. Using correct units, and I haven't talked about units yet. So what have I found? The change in W, which is degrees Fahrenheit. So this is degrees Fahrenheit per, because we're dividing by time, so per minute. So using correct units, interpret the meaning, wrong one. Using correct units, interpret the meaning of your answer in the context of the problem. So I would say, forgive my handwriting, at time 12 minutes, the water temperature in degrees Fahrenheit is increasing at 1.016 degrees per minute. There you go. All right, let's go on to part B. And I got to keep the table visible here, so we'll squeeze it in at the bottom. So part B says use the table to evaluate the integral from 0 to 20 of Wt dt, and then interpret what it is that you find. Oh, excuse me, that's W prime of dt, which actually makes it pretty easy. So some of you might be confused at this point and trying to decide, well, what do I do, because this is the value of W, not W prime. Well, let's just look at this integral that they're asking me to solve. And they're clearly saying, let's find the antiderivative of W prime. Well, we know that the antiderivative of W prime would have to be W, because that's their relationship. So then I evaluate it from 0 to 20, and I simply get this statement that says W of 20 minus W of 0. So W20 is 71 degrees from the table, minus W0 is 55 degrees, again from the table. And so what is it that we have found? First of all, it's going to be 55, 65, what's that, 26 degrees? So that's the answer, and then once again it says explain the meaning of what you've just found. So we have just evaluated W of 20, which is the temperature at time 20, and W of 0, which is the temperature at the beginning, and found that the difference between them was 26 degrees. So I would say during the first 20 minutes, maybe first is a bad idea, but during the 20-minute time period, let's do that. During the 20-minute time period, from, and again, maybe this is really redundant, but you get the idea, from time 0 to 20, and maybe that's all I really need to say. Maybe I didn't even need to mention this, so maybe I should just start here. From time 0 to time 20 minutes, the water temperature went up 26 degrees Fahrenheit. And that should do the trick. Part C. Alright, use for 0 to 20, the average temperature is found by adding up all the temperatures, so the integral from 0 to 20 of W of t. So that adds them all up, and then we divide by 20, or multiply by 1/20th to average it out. Is this an overestimate or an underestimate? And explain your reasoning. Okay. So I can't really see my table, so this is going to be a little annoying, but I'm using left Riemann sums, it says. Let's just double check that. So the width of each interval, let's go back and take a look here. This is 4 units, and then 5 units, and then 6, and then 5. So the widths are not the same. And we're going to use left Riemann, so that means the first rectangle. So if we were to sketch a picture of this, and we have our points that they gave me, then the first rectangle that we create is going to have a height of 55. And the second one would have a height of 57. The third one would be a height of 61.8. Etc., etc., meaning we won't end up using the one at 20 because then that'll extend beyond. Alright, so let's zoom out just a little bit here. Alright, so the width of the first interval is going to be 4 units, and the height is going to be 55, plus the width of the next is going to be 5. The height is 57, and what do we say? That's 4, that's 5, that's 6 units from 15 to 9, and the height will be 61.8, plus the last one was 5 unit change and 67.9. So that'll get me the total, so I'm going to need to take that answer, and we should write what we mean. So if I put an equal sign there, this had better equal that. So I should really put my 1/10 out here as well. So you get 1/10 of, to the calculator, 4 times 55 plus 57.1 plus, this makes for some riveting television, I'm sure. 8 plus 5 times 67.9 4 times 55, 5 times 57.1, 661.8. All right, good. So I did that pretty quick. Hopefully I didn't screw it up. I get 1211. So then I divide it by 10, and that's going to give me 121.1. All right, so let's read the question. Use a left Riemann 4 subintervals to get the approximate value. Does this approximation overestimate or underestimate? Okay, so this is 121 degrees Fahrenheit, and that's the average. Let's see if that makes sense. It does not make sense. I have made a mistake someplace. If it's 121 degrees, and that's my average, then I should be way up in the hundreds here, and my temperatures are in the 50s to 70s. Okay, so riveting television continues because I have to find my mistake. Okay, so what did I do wrong? 4 times 55 plus 5 times 57.1 plus 6 times 1.8. Maybe I'm just crazy and this is right, but it doesn't feel right. 5 times 67.9 base times height. So the whole area is 1215. That's, oh, interesting. I got a different number, but it's going to make it even bigger. 1215.8 and divided by oh, what did I do? Okay. Probably you saw it a long time ago and I'm just crazy. This should not be 10. This is actually 20. But the good news is I actually found a mistake, or I just created one of the two. Divided by 20, and now I got an answer of 60.79 degrees Fahrenheit. And let's take a look. That seems much more realistic, and we're going to assume that's correct. All right, so now it says, is this an underestimate and over an overestimate? And basically, I guess we need to look at, since we're using left Riemann sum, we need to look at the data. So the data is showing me, and actually it tells me in the question, that it's increasing. So that means my shape looks, maybe something like this, or maybe even concave down. So maybe it looks something like this. But either way, it wouldn't matter, because if I make rectangles from the left side, then I'm missing this area. So my answer is an underestimate. So does it under over? So this is an underestimate. Because what's the W? W of t is increasing. Therefore, I don't know what I want to say. That might actually be enough. Therefore, the rectangle's formed, yada yada. Don't count all the area. Very non-technical answer here. But it'll be fine. Really, I think this part right here would be enough as it is. And then let's go to part D. It says from 20 to 25, the function W that models the water temperature is given by this. Oh, has a first derivative given by this. Based on the model, what is the temperature at time 25? Okay, so now we know an equation for the rate of change. And so this becomes a very simple question of knowing how much we have at the beginning and then what happens after that. So the beginning in this case is going to be time 20. So at time 20, so W of 20 plus whatever happens from 20 to 25. So the net change of the function they gave me, W prime of t. This is what I need to do to answer the question. And so, let's see, W of 20 is, gotta look back up at the table, 71. So this becomes 71 plus, and now I need to integrate. I've already typed it in my calculator. So math 9, y variables, function y1, comma x, comma 20, comma 25 is only 2.04315 added to 71, and I obviously get 73.043 degrees Fahrenheit. No explanation needed, and so we are done. Okay, so we're at 16 minutes on this video. Let's take a look at the scoring guide. W prime of 12, find the slope, 1.017 or 16. The water temperature is increasing at a rate of approximately this many degrees at time 12. 2 points, one for the estimate, one for the interpretation, and that's what we have as our answer. So we've got 2 points. Part B, they said integrate the derivative, exactly what we got, W20 minus W0, 16. The water has warmed by 16 degrees over the interval from time 0 to time 20. 2 points. Part C, exactly what we did. And they got 60.79, which seems familiar. Yep, that's what we got. So 1 for setting it up as a left, 1 for getting the answer, and then 1 for the underestimate. And it says it's underestimate because a left Riemann sum is used and the function is strictly increasing. So that's all they said. And then here's their work they did for finding the new total, 73.043. Odd they didn't put units on that, shame on them. And that's what we got. So I'm happy, I got all 9 points. And we're at 17 minutes, so let's might as well stretch this a second longer. And let's take a look at the information here. So let's go to the next page. The mean score was 3.96 for AB students. In general, they did pretty well. And that's probably good enough information. Okay, so their average is only 3.96, which you'll notice we could have gotten by just doing parts 1 and 2. Okay, I'm going to stop this video, and we'll pick up question 2 in the second one.